Welcome friends to Power Plant Guru YouTube channel. Friends, I am a mechanical engineer with around 20 years of experience in the field of power plant, and I used to create small fundamental knowledge series videos for power plant engineers. We also run doubt clearing sessions on weekends. So if you want to reach us, you can reach us through comment section and join our weekend classes. Let us continue to watch our today's video. This video's topic is sliding pressure control in steam turbine systems. One of our viewer has asked this question to explain sliding pressure control. So that is why we are picking this topic here to explain basic concept for how what is sliding pressure control and what are the pros and cons for this. So, all of you must be aware that if we talk about boiler and turbine system, there are certain terms like BMCR and TMCR. That is boiler maximum continuous rating or turbine continuous maximum rating. So this number is what is the designed pressure, temperature, and flow which boiler will generate, and then what will be the power generated by turbine at that particular load. So what happens, let's say this turbine capacity is one 115 megawatt, this boiler is 500 tons per hour, something like that, for an example. So the boiler is generating its steam, and then at the desired pressure, the pressure is 120 bar, let's say for example. So boiler is generating that steam at this pressure and temperature, and turbine is operating at 115, that is full load. Let's say turbine has to reduce the load to 80 megawatt. What will happen? How it can be done? So what will happen? This turbine control valve earlier, let's say it was 90% open. So what it will do? It will be somewhere 80, 85 or 70 somewhere. It will reduce. It will reduce so that the flow which is going into the turbine that will reduce, and ultimately energy is reduced, and then megawatt is reduced. So what will happen? The pressure, temperature remains same, and flow reduced from boiler. So to maintain this, lower pressure inside the lower flow inside the turbine, but pressure before this valve, this control was remains same. Whatever boiler is generating, just whatever losses, piping losses are there. After that, this pressure is same. So what this turbine control valve is doing earlier, let's say it was 100% open or 90% open, and now it is 80% open. So what it is introducing, there is a loss. This particular blockage or obstruction is creating a loss in the system. So this is a loss. To overcome this loss, if let's say we consider a case where based on turbine output only, let's say it was earlier it was 115, now it is 80. So this based on 80 megawatt only, this pressure is controlled. Let's say I want to fully open, keep this valve fully open, always 100%, so that I am not incurring any losses here, no losses. And what I will do, I will reduce the pressure only here, upstream boiler pressure only I will reduce, so that this valve is always fully open and I am not incurring any losses of throttling here. So this operation is called sliding pressure. What is sliding? Based on 100 megawatt, there will be a set point which will be turbine based on loading. The pressure will change, boiler pressure. Let's say it reduces to 80. Then it is different pressure. Let's say it reduces to 75 megawatt. Then it is a different pressure. So based on load, or the steam demand by the turbine, the pressure is changing. It is sliding from this point to this point to this point. So that is called sliding pressure to avoid this loss. There is another thing. So if you have understood this concept, so there is another thing. Let's say your boiler is operating at 120 bar. So there will be definitely a boiler feed pump. So that pump is supplying water to the boiler. And if it is 120 bar all the time, 120 bar at 115 megawatt or 120 bar at 80 megawatt or so. So then what your pump is doing a lot of work. So if you change the boiler operating pressure like that in a different, reducing way, how the load is reducing, then you can reduce the discharge pressure. You can maneuver the boiler feed pump also to have a lower discharge pressure. By that, you are reducing the work done by this pump. So ultimately, here also you are reducing your losses, and here also you are improving on the energy consumed by boiler feed pump. So those two things are making your system more efficient. So this is how sliding pressure control is beneficial in power plants to make the system ultimately more efficient, ultimately more economical. But what is does this include any problem also? So let's say my plant is running at 80 megawatt. I'm taking an example. My plant is running at 80 megawatt, and my this control valve is full open, and suddenly I got a signal to increase my load to 100 megawatt. Then what I have to do? I don't have any margin here in this sliding pressure because my valve is full open. What I will do? I will wait till my boiler pressure increases, then only I will be able to increase my load. So this is a drawback where in dynamic plant system this will not work, where rapid load up and down is required. For that there is a concept of modified sliding pressure. Modified sliding pressure. If you see this plot, you have this two lines here. You have two lines. One is your pure sliding pressure control. Another is modified sliding pressure control. So if you see here, there are the y-axis is pressure, the x-axis is percentage of load. So whatever I have explained, that is this one, pure sliding pressure. But to have some margin, for load change up and down, there is a calculation, inbuilt calculation is done. Based on that, it is having little more margin, some more flexibility is there. It is always on a little higher side. You see from this point, let's say for 60% load, the pure sliding pressure is something less than the modified sliding pressure. So this much margin you will have to increase your immediate load. So that is a thing where the sliding pressure control has a problem to have a high ramp up. So to overcome this problem, the modified sliding, which is this red line, modified sliding pressure is introduced. So this is how on a very basic level the sliding pressure and modified sliding pressure concept is can be understood. If you have any question, you may please ask those question in comment section. I would be trying to respond whenever I get time. And if you have our membership, then you can ask that in our chat box also. We will try to respond to them also there as well. Thank you very much for watching Power Plant Guru. And if you want to ask certain topics where we can provide a new video, please mention those new topics in the comment section. Thank you. Thank you very much for being with us.